So, 41,000 feet and Mach 0.84 in a 737. You're probably going, what? Hi there. My name is Ron Rogers, and I'm going to tell you about a flight test I did on the Boeing 737-800. Now, I'm type rated, was type rated, still am, I guess. It doesn't go away on the 737, and of course they're stretching the string here for all the models, and you stay type rated. Don't type rated on one, type rated on all. But all right, so here's a depiction of the 737 aircraft, and of course on the left there, it's kind of hard to read that chart. I blew up this little section of it. This is just basically the 737s with a little 717 thrown in there. I did a flight evaluation on that also, and I'll talk about that at a later date. But in the depiction there, if you want a 737 that's 2 foot longer or shorter than another model, boy, they got one for you here. And that shows the 6, the 7, the 8, and the 9. Of course, I flew most of these aircraft in flight test or in operational flying. I was off of the committee before they got into the Maxes and that, and I'm not sure if the committee even ever flew that because the relationship with Boeing degraded, unfortunately. Actually, it degraded with the test pilots, even not knowing the full capability of the aircraft. They were test flying, but I digress a little bit there. But anyway, this is the lineage, and that's where the aircraft that we flew fits into the overall scheme of everything. Now, ALPA on the engineering and air safety side was going through a lot of reorganization. You know how it is when you get a new guy in charge. He's got to come in and change everything that's been working for years. Well, I think it was a mistake to what they, how they changed it, but, I wasn't in a position to say anything. But I was chairman of the ALPA National New Aircraft Evaluation and Certification Committee, been chairman of that since '92. And I was also on the Airworthiness Performance and Evaluation Committee. Well, they wanted to convert the two, so for a while I was chairman of both of these committees, and these were very large committees, and we had a lot of people on them. And later, I was chairman of those committees, and then later I became director of Aircraft Development and Evaluation Program. That was later changed into the IF-ALPA Aircraft Design and Operations Committee, and essentially it's they were shrinking the number of committees to actually make the staff work out better. That was the whole thing, purpose, I guess. But I think they really diluted the whole process. I had put together some really good people on a really good committee. It was taking actually quite a bit of time to do this. But let me talk to you. I'm retired now. I'm off the committee for many years, so I can kind of discuss this a little more frankly. And let me tell you what's kind of going on here with the structure. Now, here's the group that I brought along. There's Mike Carricker, who was the Boeing test pilot. There's me next to him. Next to me is John Cox. Now, you probably know John Cox from if you've seen the NBC News and stuff like that. John Cox was very well politically connected, and he had been on the Airworthiness and Performance Committee, and I picked him up kind of as a legacy. Now, I had worked for a very long time to, let's say, clean up the committee, and I'll show you one of the charts here in a second. I worked for a very long time to do that because initially when I got on the committee, we weren't getting any flight evaluations. We weren't getting to fly the airplanes, and a lot of, it's a great committee, but a lot of people weren't all that interested who had the appropriate background. But I wanted to bring people on with engineering and flight test background, extensive aircraft background, and a wide range of airline flying experience. And I had some legacy people on my committee. Dead weight's the only way to put it. But man, there was this one guy who actually did virtually nothing. I tried to get rid of him, and the uproar from the airline was unbelievable. And finally, he left on his own, and it was like, thank God, because took a slot and contributed nothing. But it took a long process to turn the committee over, and I was extremely proud of the quality of people that I had on the committee. But okay, those of you who know John Cox have seen him on TV and stuff. Uh, John was involved in the U.S. Airways 427 crash, and because of that, and he had a lot of 737 experience. In fact, he probably was one of the most 737 experienced guys I had on my committee. But besides that, and a little time on the Airbus 320 and that, John essentially had no international experience, no flight test background of the type that I considered valuable. And just he did a very powerful niche, and that's why he was important to have on this flight. But as far as being on the committee, I was trying to get better people on there. But anyway, yeah, okay. And then Jim Knutson, who was a Delta pilot with a lot of 737 experience. So that's the people I brought along. Mainly, I brought John for a lot of the crossover stuff. And if you're familiar with the initial, what happened in the U.S. Air 427, you know that there was a rudder hard over before they redesigned the power control unit. There were a lot of problems with that, but so there was this crossover speed where you want to be going fast enough that you had more aileron and roll authority than you had rudder authority, so you could fly the aircraft. So crossover speeds in various configurations were critical there. And John was working, he first got hired by Piedmont Airlines, and he worked for U.S. Airways. And he left in '05 because he was worried that the company was going downhill. But of course, American bought him in 2015. And, as far as I'm concerned, that was kind of a mistake. You should have stayed with him, John, because I don't think he's probably as well off financially once he got out. But that's just my personal opinion for what that's worth, and probably not much. But let me tell you about my committee. Okay, it's probably hard to read, but I had a bunch of people on this committee with a bunch of different aspects and abilities and that. And I think I'm going to do a presentation on just the people I had on the committee, because I've talked about the rise and fall of the committee, but I want to talk about the people I had on the committee and the people that I had to turn down because I didn't have slots for it. I turned down president of the Society of Experimental Test Pilots. He became president of that later, but I knew of his quality there, stealth pilot, test pilot. I mean, I had some people that were just excellent, and I couldn't bring them on, and that was a big sad thing. But okay, let's get back to this flight evaluation. Now, there's a little interesting aspect I'm going to discuss here. Okay, we all know about the standard nice display here where we have the PFD and the ND. I don't display the ND, the navigation display here, but this is the sophisticated type of display that you want on most modern aircraft, and this is what we have. Well, as you all know, Southwest is a very big 737 customer. That's all they fly. So, and they fly a legacy of the older models, or they did. I'm sure they've gotten rid of them by now. But they flew the older models, and they had round dials. And initially, we were going to do the flight evaluation on the 737-800. It's a flight test aircraft, so we got a lot of flexibility. That's how I could do 0.84 Mach, because anybody who flies the 737s, even the later ones, going, what do you do in 0.84 Mach? That's above MMO, and it is. But in flight test, you take it 15% above MMO to check out flutter. So that was a region that we could go into legally in flight test in an experimental category aircraft. Okay, so this is the display I wanted to evaluate with what was considered the more accurate single Q, but that wasn't available because they had it in the configuration of what Airbus used. I mean, what Southwest used. And here we go. This is the display. It's the single Q with the EFIS map display and the little round dials there. Well, that keeps with the training issues of Southwest. They've got basically the round dial situation there, and you notice the yellow arrow there is pointing to the RMI. And I joked with the Boeing people. I said, you're only showing half of the RMI, radio magnetic indicator. I said you need a little slot there on the bottom so you can get the whole display depicted. And that was kind of yuck yuck. Okay. Well, this is a general picture of the 737-800 cockpit with the more typical PFD ND display, which is the more common one that most the people who fly it have. And if you remember the engines, unlike some of the earlier models, and I knew the guy who designed the cowling on the 737-300 that had the quite flat bottom. You can, passengers would think, boy, did you bang those engines on the ground, and damage the bottom of the cowl here? Well, it's a little less flat due to the way they redesigned the pylon, but as you know, on the MAX airplanes, that redesign of the pylon and the positioning of the engine and the flight characteristics that resulted in low airspeed got him into trouble. And here, of course, is the nice interior of the 737, and that is a United Airlines configuration with the screens there. But let's get into the actual flight evaluation. All right, the actual flight evaluation. I conducted it on February of '98, and here is the evaluation in the magazine, and I've posted a PDF link so you can download the article if you want. And the little yellow arrow there shows it in the index. I like doing that. I'm still second from the bottom, and I still got front page coverage there, so still in the running. Okay, now let's talk about this evaluation. And I started off talking about taking up to 0.84 because anybody who flew the earlier model 737s know that you get into Mach Buffet, the thing doesn't go fast. It's the Boeing speed bump at altitude, It's the slow cruising airplane. Well, it's able to cruise now a lot faster, and basically I took it up to 8.4 at 410, and it was kind of funny. We're talking to Center. Now, this airplane had been in flight test for a while, but Center was kind of going, they actually asked us when we request for 410, and they saw our speed, they go, you're a 737, right? They were still not quite used to these airspeed parameters, because the MMO is 0.825, and the normal cruise speed is 785 to 0.795, which is much higher than, of course, the normal cruise speed of the 737s, which was down around, in the older models, 7.4, that sort of range. Now, I talked about the individuals we had on the committee that were coming, and the people I brought on. I was the actual only primary committee member on this evaluation. I brought people on who had 737 experience, which is something we used to we like to do. And of course, as you all know, the 737, that's one of the best-selling airplanes out there. And until Boeing got in trouble, and lately it's been a disaster with the MAX issue, the MAX crashes, the door plugs blowing out and stuff like that. Okay, but for the longest time, it was a very great airplane, and I started out on the 737-200, and I flew all three seats on it. Yes, they had a flight engineer back there then. What a absolutely worthless job. And I went on furlough, and they got rid of the job while I was on furlough, and even though it probably lengthened my furlough for about a year and a half, I was glad I wasn't coming back to that. That was just a terrible position for anybody who flew it. But of course, one thing Boeing's trying to do is keep a common type rating. And I showed you the picture of the cockpit there. One thing nice about the old 737 is when I walked in the cockpit, I still bumped my head on the window heat switches up there that stuck out. And of course, it's better than the DC-9 windows, but it's still small windows. And to change that, they would have to redesign the cockpit, and it'd be a new type certificate, and that's tons of money, and they're just trying to save money by stretching the rope forever. And I asked him, how long are they going to stretch this darn thing? It can eventually get you into trouble, as it did. And on most of the modern aircraft now, you start the engines, the generators automatically come online. Nope, to keep the commonality of the type rating, you have to put the generators online like you did on the 737-200. But if you forget, fortunately, it's made so it's not a totally stupid airplane. It will come online and bring those online. And so we had a very nice discussion about the various display aspects with Ken Higgins, who was the director of flight operations at the time. Ken has passed away. Ken was a very interesting individual, and he actually has a brother who worked for Boeing too, and I met him, which is kind of interesting. But Boeing had some very great people. Him and John Cashman actually took his position as director of flight operations. And the funny thing was, Ken had the corner office, and I digress here. Ken had the corner office that faced the flight line. John had a corner office too, and John told me, you got to be careful when they give you a corner office that you know which corner it is in, because he had a very nice view of the parking lot. But now, as I was saying, the 737-800 is basically an upgraded stretch 10 feet longer than the 737-400. It's got a maximum takeoff weight of 172,500 pounds and a maximum landing weight of 144,000 pounds. And of course, I showed you the engine there. That's the CFM 56-7, and it's rated at 26,000 pounds of thrust. And for our flight, we were using the number 2 737 flight test aircraft, and it was fully instrumented, which is very important because you do stalls in a large aircraft like this. You can get a lot of interesting airflow back around the tail, and there's a danger that you could actually exceed certain structural limits on the tail due to the buffeting. Buffeting can be very severe in this when you actually take it in the stall, and I'm not talking about what you typically do in the simulator where you get the stall warning, the stick shaker, and then you recover. That's a stall warning, of course, above the actual stall. We take it in to actually look at the stall characteristics. And I started out flying the aircraft. I gave the seat to the other guys later to do various maneuvers as part of kind of their more expertise. But like I said, it's basically the same cockpit as the earlier design, and you can download the actual flight evaluation you see pictured here, and read this stuff in more detail at your leisure. Now, being a flight test aircraft and kind of early in the program, there are all sorts of little glitches you can encounter. When I set the takeoff thrust, the auto throttles clicked off. So I ended up setting the EPR, the exhaust pressure ratio gauges manually, but my character said that since the engines have a full authority digital engine control, they didn't have it on the 200, and that I was had most of my time in. He says, since we have FADEX, he said I could have just shoved the throttles right to the firewall, and the FADEX would have kept me from damaging the engines, basically overpressuring them, over temping, and things like that. And like I said, the details in the article, and I'm not going to go over a bunch of little points here, but some interesting things are we were climbing at 0.78 Mach, which is an impressive cruise airspeed for a 737, let alone a climb speed. And we took it up to we took it up to 410. And when I got up to flight level 410, the weight of the aircraft was down to 128,500 pounds. And at 410, I was able to roll into 45 degrees of bank before I encountered any Mach buffet. Now, this is the part where I did the slight descent to get it up to 0.84, and so there was essentially no Mach buffet like you'd see on an earlier 737. And I did some simulated emergency descents. We wanted to get down to do some stalls at a lower altitude, and I brought it up to 257 knots, 0.81 Mach, near the MMO, 0.825, and I was getting a descent rate clean of 2,500 to 3,000 feet per minute. I pulled out the speed brakes, and I'm at 5,500 to 6,000 feet per minute rate of descent, and I flew basically 0.82 Mach on the descent until I picked up the VMO speed of 340 knots. Now, the wing on the 737 600, 700, and 800 has 25% more area the wing on the older 737s. And also, one thing they did was they got rid of what's known as a cusp under the leading edge older aircraft, and that contributed a lot to the mock buffet. And with the new design, essentially they have eliminated the mock buffet and did various clean and configured stalls. And the aircraft had very significant buffet in the stalls. We were getting a 0.8 G peak-to-peak buffet recorded, and basically bringing it into the stall required 15 pounds of back pull, and to get into the full stall would have required about 50 pounds. And it's interesting, I did these in the 777. I'll talk about that later. We are up to actually full back stick on the holding the yoke full back on the 777. It took 135 pounds of pull to bring the yoke all the way back in your lap. Now, I had John Cox take the seat to do the crossover control demonstration. And basically, you enter from a steady state side slip. You put in full rudder in, and then you put in full aileron to counteract the roll from the rudder, and you slow until you get to a point where you can no longer counteract the rolling tendency with the ailerons, and that determines the crossover speeds. And these are listed in the article that I've linked there. And I'm not going to go in detail, but basically to say that the aircraft performed much better than previous models of the 737 in this regard. So it gives the flight crews a lot better chance. And we did a few other things, like we shut off both A and B hydraulic systems and flew around in manual reversion. And this aircraft being an old design, and I've flown under maintenance test flights in the 737-200 in manual reversion. The aircraft actually flies reasonably well without the without the hydraulic systems, which of course you can't say for most modern aircraft anymore. But we got the thing. Oh, and I did we did a demonstration of lowering the gear manually, and normally it takes 80 pounds of pull. Anybody who's done that, probably in the simulators, the 737 pilot, it takes a pretty good pull to release the gear from the up locks, and they descend. Now, you'd send the one of the pilots back to mid-cabin level to check that there's a little disc back there under the carpet. You got all the passengers back there. There's a little disc under the carpet, and you pull the carpet up, you open up the disc, and you take your flashlight, you turn the wheel well lights on so you can see, but you look to see that the gear is down. And a friend of mine told me a story where they had to go back and they had to do a manual gear extension on the 737, and he's down there on his hands and knees looking through that little window, and this lady taps him on the back and says, "What are you doing?" And he says, "Oh, we're just checking for the animals in the hold, make sure they're all right," and close it back up. And I guess they didn't go into an extensive analysis to the people that they had a gear problem. I don't know exactly what happened, but he was having a little fun with the passenger, a little disingenuous analysis of the situation there. But airline pilots can be a pain in the butt at times. Anyway, we powered the aircraft back up. We did some Cat 3 dual landings. We had a 200-foot ceiling, so it wasn't a VFR day, and it was fairly reasonable on weather, but it certainly wasn't a Cat 3. And the weather improved, and I came back to test PIO, pilot-induced oscillation characteristics. They now call it. They're trying to make sure they don't embarrass pilots by calling it a pilot-induced oscillation. It's called APC, aircraft pilot coupling. So it's supposedly not as make you feel bad if you get into one of these, but basically what you do is you do a lateral offset of the runway at about 500 feet, and then you do an aggressive maneuver back to line yourself up with centerline, and during that you can enter possibly a lateral PIO. Anyway, that's the reason to check that out. And we did a little bit over other flying there, did some touch and goes. Mike pulls an engine on me. I do a simulated takeoff. We come back around land. We get ready to do another takeoff. And now one thing that kind of concerned me is the takeoff trim is not on the takeoff warning horn, the rudder trim. And we had, quite a bit of rudder trim left in, and I happened to notice that. And I said, it'd be nice if they put that on the, the takeoff warning horn. And Mike Carricker said, well, most people don't do a single engine landing and then do a takeoff after it, so I had a point there. But there was an accident where rudder trim was improperly set. I believe it was at LaGuardia, and they went off. They aborted and ended up going off the end into the pier there. And I'm sure a lot of people are familiar with that. But anyway, we switched the seats out, and Jim Knudsen got in there, and we had about 5,000 feet of runway. Mike Carricker positioned the aircraft, and we were going to do a practice RTO. And I know I got some funny responses of a practice RTO. Yeah, that's a rejected takeoff. And as I mentioned before, the brakes on this aircraft can be impressive. Now, this aircraft has steel brakes. They don't have enough room for carbon brakes, so they had to go with steel, but they're still very impressive. And we were going to do an abort, rather low speed, and we're not terribly heavy, so this isn't really stressing anything horribly. But it was going to be at planned at 100 knots, and the auto brakes become active above 90 knots. Before that, if you abort, you have to do it manually, like on most aircraft, because the auto brakes don't engage. Above that, if you pull the throttles back, boom, they fire. And Jim overshot the speed a little bit. He got up to 117 knots. So we had a little bit of extra energy. But let me tell you, an RTO is impressive. I mean, we were in our straps. That thing really comes to a stop quickly. It's a real eye opener. It's it's a real showstopper, no pun intended, as I mentioned in the article. So we got a very nice flight out of this, 3 hours and 38 minutes. And well, we got a very good evaluation between the three of us, and everybody got to kind of look at their own little niche and expertise in the aircraft. So that is the story of our 737-800 flight evaluation back in '98. That was the last 737 flight evaluation that I performed. Like I said, I was out of the committee before the MAXes came along, and this was still the time when Boeing had a good history with the company and the 737 series of aircraft. And of course, we all know what happened after that and how things went downhill, which is very unfortunate. But the 737, very good, very capable aircraft, in spite of the later unfortunate situation with the company. So anyway, thanks for watching. I hope you enjoyed it and found it informative and interesting. Thanks very much.